Hello, students. I'm sure you're supercharged to learn more about current electricity, aren't you? Okay, let's recall. What do you see here? That when the electrons are flowing in the circuit, the bulb glows, right? So the charge in motion constitutes the current. When the electron stops flowing, the bulb does not glow. Well, this brings me to a question that if I have a copper wire, we all know that metal atoms contain free electrons, right? Like copper is a metal and has free electrons, valence electrons. So if I give you a copper wire, do you think current electricity is flowing through it? Well, let's dive into the copper wire and see its atoms. The red circles shown here are the atoms of the copper uh, wire, and the blue small circles are like the moving electrons, the free valence electrons. But how are they moving? They are moving randomly. Whereas when you dive into a conductor where the same metal wire is conducting electricity, the electrons are flowing in one direction. So, what is the triggering factor for these electrons which make them move streamlined in one direction? Yes, it's the electric cell. Today, we need to understand it is the potential difference of the electric cell which is responsible for the streamlined flow of electrons constituting the current. So, today's objective is to understand the concept of potential difference. Let's know more about this cell now. We know inside the cell there are a lot of chemicals. So when the cell is put into use, which energy would be converted to electrical energy? Definitely chemical energy is converted. Now, what is there in the cell that determines the direction of flow of charge? If you have noticed, there is a plus and a minus sign. Yes, they are the two terminals of the cell, known as anode and cathode. The anode has deficit of electrons and so also known as positive potential. Deficit of electrons means having less amount of electrons, whereas cathode has excess and so it is also known as negative potential. Now, when you connect a wire between the positive and the negative terminals of the cell, that means between the anode and the cathode, can you guess how the electrons are going to flow through the wire? Will it be positive to negative or negative to positive? Yes, definitely they will flow from where they are in excess. They are excess in cathode. So they are going to flow from cathode to the anode in the external circuit. But how long will the electrons move in this circuit? Surely they stop. So they will move as long as there is difference in the electrons at the two ends of the cell. Like if this is cathode is excess, more number of electrons, here less number of electrons, they keep on flowing until they become equal, until the concentration is equal. Just like if you have water in one beaker at a higher level and water in another beaker at a lower level, and if there is a connection, the flow of water is definitely from A to B. And this is because of difference in hydrostatic pressure. So water will flow until the level is same in both the vessels. Once the level is same, the flow will stop. Similarly, you see if you have a body, if you have an object A which is at a higher temperature and B at a lower temperature, the flow of heat will definitely be from A to B. But how long will this heat flow. It will flow until both the bodies acquire the same temperature. So similarly, how long will the current flow if I ask you? It will flow as long as there is potential difference, which in simple terms means difference in the level of electrons. Excess and deficit. As long as there is difference, excess electrons is negative potential, deficit electrons is positive potential. So as long as there is difference between the two ends of the cell, the electrons will flow and so the current will flow. But how do we know how much is the potential difference? Well, there is a device which measures the potential difference. You can see here, this device has two ends which are connected to the two ends of the cell, and it is showing the reading 1.5 volts. Well, if you connect both the wires at the same terminal, will it show any difference? No, there is no difference shown, although there are excess of electrons at the negative terminal, but this machine or this device is showing 0 volts. It is not showing the difference. Similarly, if the same device is connected to a cell which is being used for quite some time, it is showing that the cell is drained. It is showing 0.07. The voltage is decreasing. And finally, when it becomes 0, the cell will be of no use. There will be no potential difference. And if there is no potential difference, the current will not flow. Now, do you know the name of this instrument which is used to measure the potential difference? Yes, it's the voltmeter. You connect the voltmeter in the circuit. If you remember, it is connected in the circuit across. It is connected in parallel in the circuit across the load. And if you see, the positive of the cell and the positive of the voltmeter are on the same side when you draw the electric diagram. Okay. We know charge is represented by which letter? Can you recall? Q. Current represented by letter I. That's good. Potential difference is represented by letter V. Fantastic. And the reason it is called V and not P or D, because electric potential difference is also known as voltage. So that's the reason it is represented by letter V. So let's recall again. Electric charge symbol is Q, unit measured in coulombs. Current measured in amperes. Potential difference symbol is V and measured in volts. Remember, V is the symbol of potential difference because it's also called voltage. And volts, when you write these units, make sure you're writing in small caps. But when you are giving an abbreviation of coulombs, it is capital C. All these quantities are definitely scalar quantities. So let's summarize again. Here we have the metal wire. Electrons are moving randomly when no cell is connected across the wire. When you just have a plain wire, if you touch the wire, do you get a shock? Not at all. But when cell is applied across the metal wire, these electrons are streamlined. They move from one end of the wire to the other end, from cathode to anode. Let's summarize more. You can see who is responsible for making and breaking of the circuit? Yes, it's the key. What acts as a conductor for the electrons to flow from the cell to the bulb? That's the wire. And What works as a source of electrons? Yes, it's the cell, electric cell. So let's create an electric circuit. Let's take this up as an experiment. And there you go. Only when you press the key, the electrons start flowing. Have an electrifying day. Thank you.